Greetings, greetings. I'm Mr. Moyo. Okay, we're continuing with our revision here, where I'm actually looking at question 2. So, like what I said, those who are new to this, I've done 2 videos already, 3 of them. So we're just finishing the questions. We've already answered question 2.1, 2.2, 2.3, and also 2.41. We're now on question 2.42, where we're supposed to calculate the detention in the code connecting the 2 blocks. So if we're looking at the 2 blocks, we've got this code. So as this body is moving to the right, we want to calculate the tension. The first part is to try to draw the free body diagrams of all the 2 bodies. So this is our 3 kg free body diagram, we already have it, and this is our 1.5 kg. Then the next part on this question is to write expression of net force on each. Then after writing the expression of net force, so we're going to write the expression of net force on 3 kg and the expression of net force on 1.5 kg. Then, so for each case, if we identify the horizontal forces, so I'm going to use the horizontal forces. If we're looking at 3 kg, we've got tension and the force of friction, which I'm going to call F1. Then on 1.5 kg, if we look at the horizontal forces, we've got tension, which is acting to the left. Then the horizontal component of our force, after resolving this force, we found that there is a horizontal component. So it's going to the right. So that is the horizontal component of our 25 newtons. Then plus minus F2, which is the friction on the 1.5 kg. But we've already realized that to get this friction, we're supposed to find the normal force on each case. So the normal force on 3 kg, using the coefficient of friction and the normal force, so we find that the frictional force on 3 kg was 4.41. Then the frictional force on 1.5 kg was 4.08. So once we are done with that, we use our expressions of net force to try to calculate the tension. So in this first case, we'll form an equation using MA is equals to tension, this is for 3 kg, plus minus F1. Then we substitute 3A, that is the mass, T minus F1, then 3A becomes plus 4.41 is equals to T. Then we hold this equation. We go to 1.5 kg. We just do the same. We substitute the MA is equals to 25 cos 30 minus T minus F2. So we substitute 1.5 A is equals to 25 cos 30 minus T minus F2. So by simplifying that, we are going to have this at the end. But because we know the value of T from that equation that we kept here, then we go and substitute T into this equation. After substituting, then we get 1.5 is equals to 25 cos 30. I think you can see that, plus that value of T there, which is 4 plus 3A plus 4.41 minus F2, which is 4.08. We have to solve this simultaneously, so you should be good in your maths. You remove brackets properly. You always be mindful of the negative sign. After removing your bracket properly, you collect like terms. So this is 3A, we take it that side, it goes, it adds there. Then we form 4.5A is equals to this number. Then our acceleration, we can get our acceleration as 2.92455. I've written a lot of numbers there. Then by merely substituting from that first equation that I was holding again, T is equals to 3A plus 4.41, I substitute there. Then I get my T as 13.18. So this is the mathematical part. You should do your maths and know how to solve simultaneous equation. The most important thing that we need to know in science is to how to use the expression of net force. So in a summary, for us to, from what we have done, we have seen that to answer question 2, we need to draw free body diagrams. First of all, identify forces, identify the vertical components and the horizontal components, resolve any forces, then use the expression of net force. Always remember, F net is equals to MA, and that's how you should attempt question 2. When a force is not horizontal or non-vertical, we should resolve we should resolve and get its components. You break it into its components. So I want to thank you. I hope you have learned a lot from these videos that I have prepared. I hope you'll be able to apply the expression of net force. So go through this video again and again. So this is question 2 in your CAPS National Senior Exam. Thank you very much. I'm your teacher, Mr. Moyo, and on my WhatsApp number 078-8747-345 if you want to get hold of me. Thank you very much.